Hey, thanks everyone for coming out tonight. I appreciate your time tonight, even with the Jets game being on and everything. So tonight, what I want to talk about is exercise anti-inflammatory, a brief overview. And just so that you get to know me a little bit more so, my name is Dr. Stephen Cornish, or you can call me Steve for short. And I'm an associate professor in the Faculty of Kinesiology and Recreation Management here at the University of Manitoba. And I'm working on my 8th year now being here in the faculty. So I actually came in 2013. So this is the brief summary that I circulated to everyone. And basically, I just wanted to put it up there again so that people could read through it again and get an idea of what the talk will kind of be about tonight. So I'll just read it briefly here, but it says many individuals either take prescription or over-the-counter medications that have anti-inflammatory properties associated with them to treat a number of chronic conditions or diseases. Aging is associated with a progressive chronic low-grade inflammation that can precede a number of chronic conditions and diseases. So exercise training has been known to be a countermeasure to chronic low-grade inflammation, and this discussion will explore the anti-inflammatory effects of regular exercise training. So just a brief overview of my talk tonight. So the first part is we're going to study, look at why we study exercise and inflammation, so why it's important to study this. We're going to talk a little bit about NSAIDs, or non-steroidal anti-inflammatory drugs, as a treatment option. We're going to look at some definitions in relation to the inflammatory response and the immune response to exercise. Then there'll be a little bit of data and figures from our lab and other labs in relation to how exercise can be anti-inflammatory in nature. I'm going to talk a little bit about COVID-19 and exercise, and then summarize a little bit about physical inactivity and activity and what the recommendations kind of mention for us to do as far as becoming an exercise that is going to be anti-inflammatory in nature. So when I think about the question of why I study what I'm studying as a researcher, it came down to the fact that many papers were finding that these inflammatory markers were highly associated with the development of a number of different types of diseases. So in terms of muscle wasting or sarcopenia, or the loss of muscle mass with age, we always have known that inflammation is associated with some autoimmune diseases such as rheumatoid arthritis, metabolic syndrome, or type 2 diabetes. There's inflammation associated with that as well, and cardiovascular disease and stroke. And then basically some vascular dysfunction that can happen in terms of our blood vessels and how inflammation is associated with that as well. So one of the main reasons I study what I study, it's related to the death of my grandparents over a 6-year period of time. So one grandfather died due to Alzheimer's disease and suffered with a terrible quality of life for the last few years of his earthly journey. Another grandfather died of complications due to type 2 diabetes and congestive heart failure, which he dealt with for a good portion of his life. I had one grandmother who was diagnosed with rheumatoid arthritis in her early 30s and was actually confined to a wheelchair for the remainder of her life. And finally, my other grandmother died due to complications arising from 2 ischemic strokes that she suffered later in her life, which seemed to change her personality and definitely affected her quality of life as well. Underlying all these diseases are inflammatory processes. So indeed, as more research sheds light upon various diseases, it seems that the altered inflammatory processes may be the cause of a number of diseases, especially chronic diseases associated with aging. So I wanted to investigate if the 2 areas of research I am most interested in, exercise and nutrition, could have anything to do with reducing the fact that increased amounts of inflammation are often seen in older adults. So how many of us have taken these kind of drugs before? So non-steroidal anti-inflammatory drugs, things that you can get over the counter, such as ibuprofen or Aleve. And then sometimes there's prescription ones that we can get as well, such as Celebrex and those types of drugs that are more prescription-based drugs that are anti-inflammatory in nature. But probably most of us have taken one of these types of drugs at one point in our life or another. So when we look at these drugs, they can be effective at lowering inflammation and the pain that is accompanied with it. However, taking these drugs for an extended period of time can have deleterious consequences to our health. So I'm not saying that I don't think there is a time and a place for the use of these types of drugs, but long-term use may have some negative health effects. So are there other strategies that we can utilize to reduce the chance of having this chronic inflammation occur? And I believe that prescribing and completing an exercise program can be one way that we can use to control chronic low-grade inflammation. And I hope to convince you of this by the end of the presentation. So in this diagram here, you can see that inflammation is kind of central to a number of different disease processes. So while the link between inflammation and diseases such as autoimmune diseases and arthritis has long been known, it is only recently that we have begun to unravel that inflammation may be a link to many of the diseases that affect society currently. Inflammation is an immunological function that is upregulated during insults to the homeostasis of the individual. It is necessary and needed part of defense against foreign things that are trying to infect us, but it's also needed for the repair of damaged tissue. Inflammation is typically instigated by white blood cells called macrophages, which are the large phagocytosing or eating type of cells of the immune system. Macrophages release a variety of mediators of the inflammatory process called cytokines, which stimulate other tissues such as the liver to secrete pro-inflammatory molecules as well. Increases in life expectancy and decreases in healthy lifestyle habits have given the rise to a prolonged state of chronic low-grade inflammation. While an acute inflammatory reaction may be beneficial for the organism, prolonged, uncontrolled, and systemic inflammation can give rise to many of the diseases you see here on this slide. Currently, it seems to be unclear whether inflammation is causing the diseases or is merely a byproduct of the disease process. Nonetheless, exercise training may be one effective means by which to control chronic low-grade inflammation. So now I want to get on to a little bit more of some definitions in relation to the talk tonight. So when we're looking at definitions, basically there's 4 different definitions I want you to be familiar with tonight. One is cytokines, and cytokines are basically small proteins that are responsible for cell-to-cell communication in the immune system. So they may act in an autocrine, paracrine, or endocrine fashion. And what that means is that they may act within a cell itself. That's the autocrine fashion. A paracrine fashion is acting around cells that are close to that cell where it's been released from, or an endocrine fashion where it acts more like a hormone and gets released into the systemic circulation, into the bloodstream, and goes to a distant organ or tissue to affect it there. Now, cytokines and myokines are very similar, and there's many cytokines that are myokines. Myokines are small proteins that are released from skeletal muscle tissue. So they may act in an autocrine, paracrine, or endocrine fashion as well. And this is one of the main points that I want to make tonight, is that these myokines are released when we contract our muscle, either forcefully or for extended periods of time, such as during exercise training. Adipokines are small proteins released from adipose or fat stores in the body, and they may act in an autocrine, paracrine, or endocrine fashion. One of the things that's been shown is that when people have high amounts of fat tissue, such as in overweight or obesity, that there's more of these inflammatory or pro-inflammatory adipokines that are actually released. The last definition that I have up here on this particular slide is the pleiotropic definition. And this basically means producing more than one effect. So when we're talking about a pleiotropic effect, we're talking about how these cytokines, myokines, and adipokines can have more than one effect on the body. So they don't just have one effect, they have multiple effects that can be related to either improving or having a deleterious effect on health in general. So what is this chronic low-grade inflammation that I've been talking about? Well, basically, this is where the body is in a state of chronic systemic inflammatory stress. So we know that an acute inflammatory reaction is necessary for dealing with pathogens or things that try to infect us, but we also know that chronic low-grade inflammation is very deleterious or very negative in terms of its effects on multiple tissues within the body. So there's increased concentrations of some of these key pro-inflammatory cytokines and proteins that will be found in the circulation of the blood system. So when we look at some of these pro-inflammatory markers, C-reactive protein or CRP, tumor necrosis factor alpha or TNF alpha, and interleukin-1 beta are all considered very pro-inflammatory in nature. So they increase the amount of inflammation that's present. So if you have high levels of these types of molecules or biomarkers in your blood system, this is an indication that you have high amounts of inflammation. When we're looking at chronic low-grade inflammation, basically it's been defined as having a 2 to 4 time increase in the circulating levels of those cytokines or proteins in the blood circulation itself. Now, when we look at chronic low-grade inflammation, this is similar to the slide I had where we looked at inflammation and its influence on a number of different types of diseases. But we know that insulin resistance is associated with chronic low-grade inflammation, which can lead to type 2 diabetes. We know that atherosclerosis, or the hardening of your arteries, is associated with chronic low-grade inflammation and can lead to cardiovascular disease. We know that neurodegeneration in and of itself is associated with an inflammatory process and can lead to dementia or Alzheimer's disease. And we know that tumor growth is an inflammatory process in and of itself as well and can lead to various cancers that the body may develop over time. One of the things that has been shown in a clinical setting now is that we can measure C-reactive protein, and your medical doctor could order a test for C-reactive protein on a blood panel that he would give to you or she would give to you in relation to understanding some of the inflammatory processes that are happening in your body. Now, we all know that some of the blood panels that people do have to do with white blood cells as well. And so being able to understand what's happening with white blood cells is important. But this C-reactive protein seems to be a more sensitive marker of what's happening with inflammatory processes, at least acutely, in the body at any given time. So when it's under chronic inflammation or stress, the body will release high amounts of this C-reactive protein. And so you can see that there's low risk, moderate risk, and high risk for different concentrations of this type of protein that's released from the liver in relation to a number of different types of diseases. So when we get to the point where we're above 3 milligrams per liter, that means we're at a higher risk of developing a number of different types of diseases that are associated with the chronic low-grade inflammatory response. So the next thing that I want to talk about is this concept of inflammaging. So this is a term that was, coined quite a few years ago by some researchers. And basically they said that the inflammaging is the chronic low-grade inflammation associated with the aging process. It may precipitate the development of many different types of diseases, as we've already mentioned. And there are biomarkers that we can measure in the blood, such as interleukin-1 beta, C-reactive protein, and tumor necrosis factor alpha. They can be used to get and to identify some low-grade inflammation that might be happening in the body. So next, I want to talk about some of the data and figures that are associated with this chronic low-grade inflammation and try to convince you that this might be the case in older adults as well. So in this particular figure, this is data from our lab that's unpublished at this point in time, but hopefully we'll get it published soon, where we're looking at younger and older individuals on the x-axis and the concentration of a number of pro-inflammatory markers on the y-axis. So as you can see, in the top left-hand corner, there's basically a higher concentration of one of the pro-inflammatory markers called interleukin-4 in the older adults versus the younger adults. Similarly, interleukin-6, which is sometimes considered a pro-inflammatory marker, especially if it's elevated for long periods of time, is significantly higher in the older adults versus the younger adults at rest. Conversely to this, the interleukin-7 that we're looking at here on the bottom figure doesn't have any significant difference between young and old. So I think one of the things that we can take away from this is that when it goes to show that more than one biomarker needs to be analyzed to get a more complete picture of what is going on in terms of some of these communicators of the immune system. So it's important to measure more than one, and it's important to get an accurate estimate of what each of these markers would be doing as far as the number of cytokines that are present systemic circulation. So one of the things I wanted to point out is that the exercise response in terms of cytokines or myokines is a little bit different than it would be in terms of an inflammatory response to disease processes. So this figure here is actually from an article that was published back in 2005 called The Anti-Inflammatory Effect of Exercise by Peterson and Pedersen. So this comes out of the Copenhagen Muscle Research Group. But basically what they're showing here is in the top figure, this is sepsis. So this may be a life-threatening infection where there are high amounts of the pro-inflammatory cytokines TNF-alpha and interleukin-1 released. This is considered highly pro-inflammatory in nature and may lead to death if not treated adequately or quickly enough. With an acute bout of exercise, there isn't the same pro-inflammatory cytokines released. So if you look at the bottom figure, you can see that there's a difference in the number of cytokines released and the type of cytokine that's released as well. So there's no TNF-alpha and no interleukin-1 that's released with the exercise response. But instead of that, we see that interleukin-6 is released to a high degree, and then some more anti-inflammatory type cytokines are stimulated to be released by this interleukin-6 that increases quite substantially with exercise, a bout of exercise. So TNF, tumor necrosis factor receptor, which actually binds the pro-inflammatory tumor necrosis factor and decreases it. Interleukin-1 receptor antagonist, which actually decreases the concentration of interleukin-1, which is pro-inflammatory. And then interleukin-10, which is considered a highly anti-inflammatory type of cytokine or myokine that can be released and has an effect on decreasing the amount of inflammation that's present. So as you can see, there are differences between exercise and sepsis in this particular instance, but at the same time, we have to understand what this interleukin-6 is actually doing and where it's coming from. So the interesting thing with some of my research that I've been working on in the past few years is that these myokines, these secreted proteins that come from muscle, can regulate the inflammatory process as well. Okay, so when we look at this particular diagram, you can see that interleukin-6, which we've talked about quite a bit already tonight, is increased in terms of muscle contraction. When we look at the figure in and of itself, first, we see interleukin-6 stimulating lipolysis in adipose tissue or the breakdown of fat stores, so that there is an increased amount of free fatty acids available for contracting skeletal muscle to use as an energy source. Second, interleukin-6 released systemically from skeletal muscle causes an increased amount of breakdown of glycogen to glucose. So glycogen is the storage form of blood sugar in your body, and glucose is just the main form of sugar that your body uses for energy. These first two events seem to occur more readily when the skeletal muscle itself is glycogen, which again is that storage form of sugar, is depleted. Third, there is a feedback loop with interleukin-6 stimulating fat oxidation or the use of fat as an energy source directly in the skeletal muscle as well. So as we can see, interleukin-6 is involved in energy metabolism, both in an endocrine fashion by communicating with other tissues and communicating with itself, i.e. the skeletal muscle, by increasing the amount of fat oxidation that's occurring. Lastly here, we see the thing that I want to point out the most in this slide is that interleukin-6 can have an effect on the systemic circulation of a variety of cytokines that are involved in the anti-inflammatory pathway. We see an increase in soluble tumor necrosis factor alpha receptor, interleukin-10, which is a highly anti-inflammatory cytokine, and interleukin-1 receptor antagonism, which is another anti-inflammatory cytokine. We also see a direct inhibition of tumor necrosis factor alpha, a pro-inflammatory cytokine, by the interleukin-6 release, which happens from the muscle itself. So in this particular diagram, it's fairly similar to the last one that we looked at, except for the fact that we're looking at, on the left-hand side, acute exercise and what happens with interleukin-6. And then on the right-hand side, we're looking at chronic exercise and what happens with chronic exercise training when people complete exercise over a longer period of time. So basically what we're looking at is that the cytokines that interleukin-6 stimulates to be released from a type of white blood cell called macrophages are all anti-inflammatory in nature. Thus, the effects of acute exercise bouts seem to be anti-inflammatory in nature as well. Also, on the right-hand side of the figure, there are two types of white blood cells, or macrophages, that have two different roles. M1 type macrophages are more pro-inflammatory in nature, while M2 type macrophages are more anti-inflammatory in nature. With chronic exercise training, we see a decrease in the M1, or pro-inflammatory type of macrophage, and an increase in the M2, or anti-inflammatory type of macrophage. In general, this helps to lower chronic low-grade inflammation. In the instance of this review article, which we just published last year, we were making the argument that chronic exercise training can enhance or maintain skeletal muscle and bone health during the aging process. So sorry for the busyness of this diagram, but I just wanted to point out that we've talked a lot about interleukin-6 tonight, but here we have a diagram showing some of the purported myokines and the effects that they have on physiological processes. Some are involved in muscle hypertrophy or increasing muscle size, some in fat oxidation or using fat for energy, and some lipolysis or the breakdown of stored fat. And in some cases, it even can be used for angiogenesis or the formation of new blood vessels, which is important for delivering blood to working tissues. Important to our discussion is the role that the myokine interleukin-6 plays in modifying the inflammatory milieu. So interleukin-6 stimulates the production of those anti-inflammatory cytokines and inhibits pro-inflammatory cytokines. This myokine seems to have a multifunctional role, or like we mentioned before, a pleiotropic role. And for many years, researchers have searched for the exercise factor that links the contraction of skeletal muscle to the systemic benefits of exercise on a number of tissues. It seems that we may now have found some of these factors in the myokines that are produced by skeletal muscle contraction and released into the systemic circulation. So I wanted to briefly touch on COVID-19 and exercise training. By no means am I an expert on COVID-19, but I found this one paper that was fairly good in terms of what the recommendations actually suggest for exercise training during the pandemic. So these are direct quotes from the paper that you can see quoted on the side there on the right-hand side. But basically, I'm just going to read through these. And the first quote is that increased immune surveillance against infections has been proposed as a mechanism responsible for improving the immune response related to physical exercise. So one of the things that we can take away from this is that even though we might be in the middle of a pandemic, exercise training is still important. And getting a moderate amount of exercise training on a weekly basis or a monthly basis is very important for enhancing your immune system response as well. And then the second point basically said that similarly, regular exercise practices at moderate levels favor the function of the human body's immune surveillance against pathogens, as they stimulate an exchange of white blood cells between the circulation systems and the tissues, a fact that reduces morbidity and mortality from acute respiratory disease and infections that are viral. So as you can see from this particular slide, it's important to maintain as much of the physical activity as we can so that our body is able to fight off these infections if we are having to get one anyway. So what does the recommendations from this paper actually state? Well, basically they're similar to the WHO recommendations or the World Health Organization or the Canadian Physical Activity Guideline recommendations or the American College of Sports Medicine recommendations. Excuse me. So they recommend that asymptomatic, so people without symptoms, and healthy individuals should exercise at least 150 minutes per week for adults and 300 minutes per week for children and adolescents. It is important to emphasize that physical activity should be interrupted, and a health professional should be consulted in cases of symptoms such as fever, dyspnea, which is shortness of breath, at rest, and dry cough if they are manifested, because these symptoms can be related to COVID-19, and you should get treated for that in particular. So in summary, we're going to talk a little bit about physical inactivity and activity. So when we look at physical inactivity and activity, one of the things that I tried to convince you of tonight is that physical inactivity is a strong predictor of a number of chronic conditions. So whether that be high blood pressure, type 2 diabetes, cardiovascular disease, metabolic diseases, those types of things, physical inactivity is a strong predictor of a number of those chronic conditions. Physical inactivity is also associated with chronic low-grade inflammation. So there definitely seems to be a correlation or an association between these two things. Physical activity in and of itself may play a key role in the prevention and treatment of chronic low-grade inflammation. So in summary, physical activity increases the number of anti-inflammatory cytokines, including the interleukin-6 that we talked about, interleukin-10, which is anti-inflammatory, interleukin-1 receptor antagonist, and soluble tumor necrosis factor receptor, which is all anti-inflammatory in nature. So these are the types of cytokines that actually get released when we contract our muscles, either forcefully or for extended periods of time, such as during exercise training. So I hope that I convinced you tonight that moderate exercise training is a viable means to lower the chronic low-grade inflammation associated with the aging process. Thanks for your attention.
Thank you, Dr. Cornish. I join in again. So lots of information, I think, for us to digest. That was a very detailed presentation, and I think a lot of people will take a look at their exercise and what they're doing in terms of their health a total different way now that we know kind of the science behind it. So I will just kind of put it out to there for anybody who would like to ask a question or a comment if need be. We'll give everybody a couple minutes if they think of something. If not, I understand. And you can ask a question or you can think about it, and you can always pose it to one of us later. Great talk. Thank you very much from one of our members, Erin. Thank you, Erin. See if anybody has any other.
And if you want to contact me as well, that's totally fine later on. My email is stephen.cornish@umanitoba.ca. So I'm totally open to that as well in terms of if you think of questions later on that you want to ask.
Okay. Did you have that on maybe one of your slides that you wanted to?
I did. I was on the last slide, but I closed my slideshow already, so I should start sharing it again.
Yeah. So someone did ask, we're told to use our brains and know they use a lot of energy. Does the brain also release cytokines?
Yeah. So there is cytokines that can be released from the brain. One of the ones that's actually released from muscle that may have an effect on the brain too is called brain-derived neurotrophic factor, which may stimulate new neurons being grown in the brain in and of itself. So it may help delay the onset of some of these dementia and Alzheimer's types of symptoms and diseases, those types of things. So yes, very good question. And the brain does release some of those. And there is feedback to the brain from like myokines that are released from muscle when we exercise as well.
Right. Okay, so we'll see if you can get your email slide up, and then that way everybody can jot it down. I think I saw a few people trying to write frantically, so we'll give them a little better.
Can you see it there now?
Yeah.
Okay, perfect.
That's for everybody to see. If you wanted to jot down Dr. Cornish's email, if you come up with a question later, and that's very nice of you to offer, Dr. Cornish, that people can contact you with some questions.
No problem.
So we'll give that a little bit, and I'll see how everybody's doing there. So if everybody has that, and if there isn't any other questions, we'll be respectful of Dr. Cornish's time. We were chatting before we started that this is kind of the new norm, and all the presentations and lectures that he's giving is on Zoom. So sometimes you get zoomed out by the end of the day, we say. So
yeah,
we'll be respectful of everybody's time. Hopefully you've got his email. If not, you can email the Reh-Fit and I can pass it on to you, or someone there can give it to you. So at any point, so just in case you didn't get it. But for the time being, I will extend our sincere thanks for your time and everybody else that joined in for your time. And the Jets are winning 4-0. So it's a game, but not too nail biting. So you're not missing too much. So you still got lots to watch. So have a great night, everybody, and we will see you next week, Tuesday, for our next presentation.
Thanks, everyone, for your attention.
Good night.